In LR4-1, we're going to write proofs using the reasoning that corresponding parts of congruent triangles are congruent. You will often see the shortcut CPCTC to stand for corresponding parts of congruent triangles are congruent. And what that means in English is, hey, if I know these two triangles are congruent, all of their parts that match up are also congruent. So let's say I used side, side, side in my proof. Well, I didn't actually prove that these two pink angles were congruent, but because the triangles are congruent, everything that corresponds, so everything in the same assigned seat, will also be congruent. So our strategy has changed a little bit from LR3-5. In LR3-5, when we were just writing triangle proofs, we did this much. We had 3 congruent parts, and then we said this triangle is congruent to that triangle. We're going to add one more step. So now we're going to say, hey, because those triangles are congruent, this part's congruent to that triangle, or this part, because of CPCTC. You can also write if triangles congruent, then parts congruent. If you want to write out what CPCTC stands for, you can absolutely do that as well. So our strategy is right up here for us. And we're going to do a proof together. So we're given angle O and angle Y are right angles. So I'm going to mark that. And we're given W is the midpoint of OY. Well, if W is the midpoint of OY, then these parts must be congruent. And we're asked to prove angle B is congruent to angle T. So in looking at my picture, I'm going to be able to prove that my right angles are congruent. I'm going to be able to prove my parts are congruent. I'm going to put a little 1 and 2 here. I can prove those are congruent because they're vertical angles. So I'm going to start by just proving my parts are congruent. So I'm starting with what I was given. Angle O and angle Y are right angles. It was written out for me, so that is given. Because they're both right angles, I can say angle O is congruent to angle Y because all right angles are congruent. Then we were told W is midpoint of OY. It was written out for me, so my reason is given. Because that was given, I can say OW is congruent to WY. My reason is either definition of midpoint, or I can say W is midpoint of OY. Notice on these first few, friends, I had to have this as a statement before I could use it as a reason. Likewise, I had to have, hey, these are right angles, before I could say all right angles are congruent. Okay, so you have to use what you're given and then use that given as a reason. You have to state it first. Okay. Lastly, then we said angle 1 is congruent to angle 2 because of vertical angles are congruent. I have 3 congruent parts now. I have those angles congruent, this side, and these angles. So I've named my 3 congruent parts. Now I'm going to say this triangle is congruent to that triangle. So I'm going to say triangle BOW is congruent to triangle B matched up with T, O matched up with Y, W matched up with W. I had 2 angles in the side in between them. So it's angle, side angle. All right, I've done that step. My very last step now is going to be this part's congruent to that part. I'm always using what I was asked to prove. I'm going to say angle B is congruent, and then I'm going to double check. B is in the same spot as T. And that's what I was asked to prove, so I know I did it right. And my reason is that corresponding parts of congruent triangles are congruent. If you would prefer to write CPCTC, you may. If you would prefer to write if triangles congruent, then parts are congruent, you can do that as well. All right, we're going to do another one. This time we know CA equals CE. So this whole side and this whole side. And angle CBF equals angle CDF. So this angle and this angle, I'm going to put a little 1 and a little 2 in there. And then I'm going to actually split these triangles up. So I have a triangle like this, where this is C, D, A. And then I have another triangle like this. And notice those overlap there, so C is in both. Where this is C, E, B. That was angle 2. And that's that side. Angle C completely overlaps in both of those triangles. So I can say angle C will be congruent to itself by the reflexive property. Right, so I've found my 3 congruent parts. Now I just need to write out my proof. I'm going to start with what I was given, which is CA is congruent to CE. I was also given angle 1 is congruent to angle 2. And then we determined that angle C was congruent to itself by the reflexive property. All right, we've named our 3 congruent parts. Our next step is to say our triangles are congruent. So I'm going to say triangle. If I do CBE, C matches up with C, B matches up with D, and E matches up with A. I have 2 angles and then a side, so that is angle, angle, side, or I could do side, angle, angle, same thing. My very last step then is to say this part is congruent to that part. And I wanted angle A congruent to angle E, and I'm going to double check A and E are in the same relative position. They're both listed last. And my reason is CPCTC, or corresponding parts of congruent triangles are congruent, or if triangles congruent, then parts congruent. All right, this next one, I'm told AT bisects angle MAK. So I'm going to put a 1 and a 2 there. Because it's a bisector, those angles will be congruent. And I'm told AM is congruent to AK. When I look at this, I also know AT will be congruent to itself by the reflexive property. So I found my 3 congruent parts. Now I just need to write it all out. So I'm going to start with my givens. So AT bisects angle MAK. That was written out for me, so that is given. Because that's true, I know angle 1 is congruent to angle 2. I can either write out my reason as AT bisects angle MAK, or I could do definition of angle bisector. I was also given AM is congruent to AK. And then we figured out that AT was congruent to itself by the reflexive property. I have 3 congruent parts. My next step is to say this triangle is congruent to that triangle. So I'm going to say triangle MAT is congruent to triangle M matched up with K, A matched up with A, T matched up with T. I have 2 sides and the angle between the sides. So that is side, angle, side. My final step then, I'm going to use a color I haven't used yet, is that this part's congruent to that part. So angle M congruent to angle K, and I'm going to double check that those are indeed in the same position, and they are. And my reason is corresponding parts of congruent triangles are congruent, or if 2 triangles congruent, then parts congruent, or CPCTC. All right, the last proof we'll do together, we're trying to prove ON is congruent to RE. That's these 2 sides. So some of us are tempted to use the great big triangles, which is something we've done quite a bit in the past. But ON and ER aren't entire parts of those triangles. They're within those big triangles, but they're not an entire side. Okay, they're part of a side. So I need to pick triangles that have ON and RE as the whole side of the triangle. So I'm looking at these 2 triangles. When I look at those, I have angle O and angle R marked congruent. I have OS and SR marked congruent. And then I can get angles 1 and 2 marked congruent because they're vertical angles. So I'm going to start just by proving those 2 little triangles are congruent, and then I can move on with the rest of my proof. So I'm going to start with angle O is congruent to angle R. It was marked in my picture for me, so my reason is given. I also know OS is congruent to SR. Again, it was marked in the picture for me, so my reason is given. And then I have angle 1 congruent to angle 2 because vertical angles are congruent. I have my 3 congruent parts. Now I can say my triangles are congruent. So I can say triangle ONS is congruent to triangle RES. That's not step 3, that's step 4. I have 2 angles and the side between the angles. So that is angle, side, angle. Once I have my triangles congruent, I can say my parts are congruent. So I can say ON is congruent to RE. And I'm going to double check ON and RE are both the first 2 letters of my triangles, so I know that I solved my proof correctly. And my reason is corresponding parts of congruent triangles are congruent, or CPCTC, or if 2 triangles are congruent, then their parts are congruent.